This is Star Talk, and I'm your host, Neil deGrasse Tyson, your personal astrophysicist. And I'm also the director of New York City's Hayden Planetarium at the American Museum of Natural History. My co-host today is Chuck Nice.
Yes.
Chuck.
Hey, Neil.
Looking good. Got your NASA uniform on.
That is correct, sir. I am wearing a NASA shirt.
NASA t-shirt. Very
Yes.
good. Trying to get in good with me. You don't need to do that. I love you no matter what.
I appreciate it, man. I really do. Actually, when I cover, I'm wearing a shirt over top of the shirt, and I have to make sure that the N stays visible.
Otherwise, it looks like ASA. Okay, fine.
Which, for some reason, makes sense when I wear it.
Today, we're talking about Pluto and the farthest reaches of our solar system. There's a lot of stuff out there, featuring my interview with Mr. Pluto himself, Alan Stern.
Yes.
He's a friend and colleague. He's the principal investigator, the PI of NASA's New Horizons mission to Pluto.
That's right.
He's also a planetary scientist at the Southwest Research Institute in Boulder, Colorado.
It's no Hayden Planetarium, I'll tell you that.
No, stop it.
Just saying.
Actually, in Boulder, Colorado, they have the real sky.
Yeah, they do. They don't. No noise pollution there. No light
pollution. Exactly.
No light pollution.
Now, people know my history with Pluto, and just in all fairness to that, I'm had to bring on somebody who's a Pluto sympathizer.
And it was
who's
awesome.
Also an expert on the solar system.
And it was great.
We're going to bring in planetary scientist David Grinspoon. David, where are you?
Hey there.
Oh, hey, dude. Your Twitter handle is Dr. Funky Spoon, which every time I hear, I got to recite it. Funky Spoon.
Dr. Funky Spoon.
You're a senior scientist at the Planetary Science Institute. And where's that?
Well, Planetary Science Institute is in Tucson, but I'm actually in Washington, D.C. We're sort of a distributed beast, the Planetary Science Institute. We have members all over the world, and I'm here. I'm part of the Washington outpost.
Okay, cool. And you study comparative planetology, which is cool. This is where you see what planets have in common and what differs among them. You're a particular expert on icy moons and Mars and Venus. You wrote a book on Venus, I remember correct. I think I own that book. What was that one called?
Yeah, Venus Revealed. I love Venus because it's so much like the Earth and so much unlike the Earth. It's both, it's a mystery.
You said Venus Revealed. It might have been a better title, Venus Unveiled. Then you get the double
double entendre going on there, seeing as how Venus, the de Milo, and
maybe the next edition I'll go for the unveiling.
Okay. So, and also you care about Pluto, and I'm told you're working on a new book with Alan Stern. What's that one called?
Yeah, I love Pluto, and Alan and I are working on a book called Chasing New Horizons.
Oh, okay.
Okay. A little wordplay there. New Horizons, the mission, and Chasing New Horizons.
And when does that come out?
It comes out next year, 2017.
Nice. Okay. We'll look forward to that. And by the way, you are one of our newly knighted Star Talk All-Stars. I'm saying congratulations, but that's up for you to say whether you want to be that or not.
Oh, I very much want to be. I'm really excited to be a Star Talk All-Star. I had a blast at our launch party and recording the first few episodes. I'm looking forward to doing more.
Excellent. And this is not your first time on the air with us, so it's great having you. So tell me about New Horizons. It already passed by Pluto, right? When did that happen?
Yeah, it happened just about a year ago, or approaching a year ago, on July 14th. 2015.
Okay.
It was a long time coming. And
so David, I remember growing up and every planetary encounter was a flyby, and that word was part of our culture. Then we got a little more expensive with our spacecraft, and they carried extra fuel, and they could pull up, slow down, and enter orbit. So no one used the word flyby, it seems, for decades. So why didn't we slow down and pull into orbit around Pluto so we can hang out there? Why did everything have to focus down into just a few seconds of close-ups, and then the thing overshoots and gets lost in the Kuiper Belt?
Like George Bush over Katrina.
Yeah, right. We're doing a heck of a job. No, you're right. You're right to relate it to that history, because the reason why our first missions to Venus and to Mars and to Jupiter were flybys is because it's easier to do a flyby. You don't have to take another big rocket and all that extra fuel with you to slow down when you get there to go into orbit. And Pluto was really hard to get to because it's so darn far away. And, we were lucky to be able to do a flyby. We had to launch a really fast rocket, throw everything we had at it, basically, just to get a very small spacecraft there.
And even so, it took how long? Even so?
It took 9 years.
9 years. Now, I've tried to spread this fact far and wide, that the first rule of any science experiment is that it needs to be completed before you die. So is that fair enough, David? Is that a fair enough first rule?
Well, I think it's a good rule. It's going to be challenging for, some of the things we would like to do in the future, like getting to the exoplanets, unless we greatly extend our life expectancy. But yeah, I tend to favor projects that I might have some chance of seeing to completion.
So you put some awesome rockets on what is otherwise a relatively light space probe, and it gets out there very fast. You get high acceleration, right?
Yeah, and then we also had to do a Jupiter flyby to further accelerate. Amazingly, New Horizons took 1 year to get to Jupiter. I mean, think of how fast that is.
Wow.
Think of, all our Galileos and Voyagers, they took years and years. New Horizons got to Jupiter in basically 1 year and then picked up even more speed with the Jupiter gravity assist.
Just to be clear, you stole some of Jupiter's orbital energy and gave it to New Horizons. Confess that.
We pilfered a little bit of momentum from Jupiter. Okay. I don't think Jupiter's going to care, but it really helped us out a lot.
So we'll get back to that in a minute, but just some facts about Pluto, named for the god of the underworld, right?
And
that's right, yeah.
And all this time I thought it was the dog. I can't believe that.
Yeah, a little bit morbid. And, there was a bit of a controversy because there was one idea that all of the features on Pluto should be named after things having to do with death and the underworld. Like every feature on Pluto should have something to do with death. And other people said, well, that would be really pretty morbid. Why don't we name features on Pluto after spacecraft and scientists and gods and, people that had something to do with Pluto.
I vote for death.
Death is so much cooler.
That's way cooler.
Yeah, but an entire planet just devoted to death? I don't know.
Hey, listen, it worked for Darth Vader.
Wait, just, by the way, he slipped in the fact that he called it an entire planet. Okay? Just kind of reminds you who kind of reminds you. By the way, what is the mass of Pluto relative to Earth's moon?
Pluto is really, really tiny for a planet or for a object that some people might call a planet. Mm-hmm. And it is, in fact, only about a sixth the mass of Earth's moon. So it's really,
Hey.
Okay, so just fess that up.
I know what you're saying, man. Listen, even a micro penis is a penis.
Time to throw to the clip.
Wait, I thought that was called a dwarf. Never mind.
So Alan Stern came to town, and I sat down with him to catch up on New Horizons' flyby of Pluto. Let's check it out. What a year it was for New Horizons. Oh, my gosh. I want to say congratulations. My gosh.
Oh, thanks a lot. New Horizons is a huge team of people. Actually, over 2,500 people worked to build it.
Oh, my gosh. And what institutions were?
It's a joint project funded by NASA, but a joint project of the Southwest Research Institute and the Johns Hopkins Applied Physics Lab. Lots of big partners in it. And also small and large corporations, everybody from Lockheed and Boeing.
Somebody's got to build the spacecraft.
And all the instruments and the ground system, mission control, all of it.
And so I'm going to ask you cliche questions like, what most surprised you arriving at Pluto?
Two things. One was just how stunningly complex the Pluto system is compared to our expectations. And secondly, the viral public response to just loving the exploration. Just people, 1 billion web hits, 10 times anything NASA had ever seen, 450 newspaper covers above the fold on a single day, every continent on Earth, even Antarctica.
So the Antarctica Daily News?
Exactly. I got a copy of it. It's not called that, but yes, they sent it to me from the pole. The one and only news. I said every continent but Antarctica on a radio show, and the Antarctic people got all upset. We covered it.
So, and I have to agree, not that I had any professional expectations for it, because I don't study planets professionally, but to see the images and the nuance and the detail, I was fully expecting it to be some pockmarked victim of whatever hits it, and then it's just that. But it had an entire surface personality that could not be explained by just things hitting it. And so I was delighted.
Yeah, we see canyons, we see glaciers, we see evidence of potentially former liquids that ran on the surface. Mm-hmm. We see really varied terrain. It's like out of a sci-fi novel, 1,000-foot high methane crystals that run for hundreds of kilometers.
So does this tell you that Pluto was plutologically active. Like, is there a word for the geology of Pluto?
Very clearly.
But it seems so little, and we don't think of tiny objects as having active geology.
That's right. But
is that a bias?
It's a bias. The lesson of planetary science is we get surprised when we go to new places. This is the first time we've been to a dwarf planet, and guess what we discovered? It's a lot more complicated than anybody expected. There's a place we call Sputnik Planum on Pluto. It's a big ice field. It's 1,000 kilometers long. It's 1,000,000 square kilometers. We can't find one crater on it. And we've age dated it from that, and it can't.
So in other words,
born yesterday.
Yeah. In other words, you age date because you have some expectation of what rate craters would accumulate.
So it's sort of like we know how hard it's raining, and you can say, well, this piece of paper has that many dots. How long has it been out there?
Good.
Versus some other piece of paper with more or less dots.
And so that paper would have been out there longer, right?
Yeah. And in the case, Sputnik Planum is the scale of the state of Texas, and it was created yesterday geologically.
Whoa.
This little planet is somehow active after 4 billion years.
Any understanding of that?
Nope.
Okay, so what people don't understand is scientists love being stumped.
We love being stumped, and we don't mind being wrong. Like, we thought Pluto would be simpler. We were wrong. This is wonderful.
David, so you're a planetary comparative planetologist, right? And so how would you compare Pluto's features to other stuff going on in the solar system? I didn't see I didn't notice anything like it out there, but you've got a better mental inventory.
It's marvelous. I mean, I'll admit to having some anxiety that in addition to just wanting the darn thing to work after all those years, I had some anxiety that maybe Pluto would be boring after all. It's small. Maybe it'll just be full of craters and not that interesting. But in fact, it's anything but. And there are features that are reminiscent of many other places. And yet there are aspects that are just all, pure Plutonian and nothing like it. Maybe the most similar place is Neptune's moon Triton, which is around the same size and, also a frozen outer solar system object that's largely composed of nitrogen ice.
So are you saying they look alike, or they actually, so you've got some chemistry analysis of what's going on the surface?
I'd say that, there's some similar features, but it's not like you would mistake one for the other.
But you have nitrogen ice, that's frozen nitrogen, I guess. What else? Yeah. What else you have?
You got nitrogen ice, you got traces of methane.
Methane ice?
Yes, and also you have some features on Triton that are probably that are surely water ice. The sort of bedrock, the strong stuff on Pluto and also on Triton is water ice, kind of playing the role that rock plays.
So just to be clear, so nitrogen ice, we know nitrogen, that we breathe that in our atmosphere. Yes. Methane is the gas that most people in urban centers would use in a gas stove.
Right.
So you're cooking with gas.
Cooking with gas, right? It's also the gas that we make ourselves.
Out of your butt. Okay, fine. Okay.
I was going to say cows.
Cows. Okay, fine. Cows. Yeah, comes out of their digestive.
Comes out of their digestive system.
Not ours. Right.
Exactly.
Okay.
Yeah.
It was a cow.
But methane, we're familiar with it as a gas, and you're saying it's methane ice, which means it's not only cold enough to liquefy the gaseous methane, it's cold enough to solidify liquid methane. And what temperature is that?
It's, minus 200. I don't remember the exact.
Okay, so
really cold.
But it's pretty darn cold.
Yeah, you could have just said darn cold, and that would have worked perfectly for us. So there also, beyond what the chemistry is, there's surface features that are intriguing. One of which people illustrated with a Valentine-shaped heart. And so, what is accounting for these bright and dark areas and these different colorations?
Yeah, well, the bright stuff seems to be relatively fresh ice. Meaning, in the case of this heart, it may be as young as 1 million years old, which in terms of, planetology is like born yesterday. There's no craters on that thing. So it's really fresh. The darker stuff is probably ice that has been irradiated and mixed in with organic stuff that, the methane, of course, because it's being irradiated by ultraviolet from the sun, makes organic stuff like we're made out of, which is one of the cool things about these bodies is that they all have some organics.
So it's a source of energy for methane to explore other chemical reactions.
Absolutely. Yeah. And the methane is, it is an ice, but it's also a gas at those temperatures. It's probably both on Pluto. And so you have this weird kind of meteorology where stuff is condensing out and evaporating depending on the season and the latitude. So you have stuff moving around on the surface too in this process of evaporating and condensing in different places.
You guys are a bit audacious, I think, in asserting that Pluto has an atmosphere when, by my notes, it says the atmospheric pressure on Pluto is 1/100,000th the pressure that we have here on Earth.
Wow.
Yeah, you still want to call it, because the word atmosphere, you say, oh, let's go there and breathe it. This is the people's first thought. And then you come out and read is 1/100,000th. So your definition is clearly different from the person in the street's definition.
Yeah, I mean, it depends on what you want to call an atmosphere. Maybe you want to call it a dwarf atmosphere. I don't care. But it's, it is gas that's gravitationally bound to a planet and interacting with that planet's surface. And there's more of it there than there is out in the vacuum of space.
So if you were on Pluto and you sneezed, you would actually get rid of the entire planet's atmosphere.
You could probably sneeze some of that stuff right off. Probably could. Which is why the astronauts should always, bring some antihistamines when they go to a planet like that.
So is there any kind of life anybody can imagine, presumably not life as we know it, but life as we don't know it, that could be sustained on Pluto, anywhere on it or within it?
Absolutely. I think the most promising...
You would say yes to that?
Yeah, of course, because the thing is, as we're finding with a lot of these icy bodies out there, there's much more activity than we thought there would be, which means there's some kind of energy source. It's internal, probably on Pluto, it's radioactive decay that's moving around.
Oh, so sources of warmth.
Stress.
Okay. Mm-hmm.
And if you've got sources of warmth on a body that's largely ice, then you figure at some depth within, there's probably liquid water. So we think Pluto probably has an ocean of liquid water at some depth beneath the ice. And there's at least some energy source, and we see organic stuff on the surface. There's probably been some mixing. So
I think you're reaching for it there, I think. But here's one I'll grant you. All right, in 5 billion years, the sun goes red giant, all right? And it engulfs the orbit of Mercury, Venus, and possibly Earth. And that makes it much warmer in the outer solar system. So will that help out your life cause on Pluto?
Definitely. I mean, as you say, I'm sort of reaching for it, for trying to find conditions that might support life today. And that's why I'm thinking about the interior. But yeah, at some point in the future, when the sun continues to heat up as it is doing now and goes, into its late stages, and the Earth zone of the solar system, what we consider the habitable zone now, gets uncomfortably warm, there may be, briefly at least, a habitable zone in the outer solar system. And yeah, Pluto might actually experience a time where you could even have liquid water ocean on the surface.
Wow. So it's like planetary real estate. First rule, buy on the fringe and wait.
Right, exactly.
That's right.
But also, wait, do you hear what David said?
System. The future's in the outer solar system.
Did you hear what David said? He said it might get uncomfortably warm here on Earth.
Yes.
I mean, we would vaporize. Right. I think that's what you're saying here. So Pluto might be the next frontier to move to when we can no longer live on Earth.
Right.
Or we just go to another solar system.
Yeah, but at least it's moving in the right direction if we go to Pluto. So
many new things were discovered about Pluto, and I asked Alan if any of that has changed anything, how we view Pluto, how people should view Pluto based on new information from New Horizons. So let's check out my interview. Other than Pluto's surface, as an object, has it changed anybody's notions of things dynamically? It's a thing orbiting the sun.
Well, with the exception of Neil Tyson, it's convinced most people that it's a planet.
Okay, I'm pummeling him now. I'm giving him a noogie on the thing.
And then when people find out that if you drove around the circumference of Pluto, it's as far as from Manhattan to Moscow, they said, I didn't know it was that big.
Yeah. I would say, whether or not anyone calls it a planet, I think I learned this word in the Carl Saganian universe, where we get to call it a world. And a world has a certain intimacy to it, a conversational intimacy, because it tells you that it's a place. Maybe we'll go visit it one day. It's interesting to think about and to explore. And maybe that's what matters here. Is it a world? The moons of Jupiter are worlds.
They're planets.
Alan Stern has planet on the brain.
Yeah, well, it's important. My field is called planetary science, so I think it's important that we, as practitioners, understand what the central objects in our field are. And where Pluto falls in that is secondary to just having a basic, logical, consistent understanding of what are planets. And there's two ways to go at it. You can go at it scientifically. And scientifically, the geophysical planet definition says that when objects are big enough to be round, by self-gravity.
Gravity shapes it.
And they're not so big that their central temperature causes them to ignite in fusion. Anything in between, which is from about 1/10 of Pluto's size up to about 10 times Jupiter's mass, will be called a planet. It's very simple. Or you could use the Star Trek test. You know, when the viewfinder comes on, the public knows in about a half a second what they're orbiting. It's a spaceship, it's an asteroid, it's a comet, or a planet. Pluto passes by either test, but really, it's really about we as scientists being able to order things into boxes so that we can categorize
So it's our problem.
in a logical way.
It's not Pluto's problem. It's our problem.
Well, Pluto's an inanimate object.
Okay, but of course, whatever is your concern about the legitimacy of the vote, our community voted in 2006 for the new classification.
Actually-
I don't believe...
Actually, not so. 4% of the International Astronomical Union was there. 4% voted. It was almost 50-50. And so about 2% voted each way, and it went the other way. On a vote made up of non-experts called astronomers, not planetary scientists, I'd like to redo that vote.
Okay, so now,
and really get the experts.
But fine, what I'm saying is, I don't think anything I did had anything to do with that vote. So, and that's the vote that sets the language. So
7 years ahead of that, running a very prominent exhibit at the American Museum of Natural History, you wanted to take Pluto and the small planets like it off the list of planets. Didn't you do that?
No, not really. No, we never had a list of planets. That's the thing. We never said Pluto wasn't a planet. We just grouped it with the Kuiper Belt.
So if I go over to AMH today, I won't find any numbers like 8?
Never. There was never the number 8. I was misunderstood.
I'm having the best time.
The press misunderstood me and my team who did this.
So Pluto's a planet.
So no, we did. The institution did not commit to whether.
I'm asking Neil.
I think.
This is where you get to make.
I think the disservice. Neil. Let me at least meet you halfway. I think if dwarf planet is a category of planet, I have no problem with that. What happened was people thought the dwarf planet meant it's not a planet anymore, and I agree. And that's where I can meet you somewhere.
Good. So
on the
I
island.
like that. Dwarf planet is a category of planet, just like dwarf stars. The sun is a dwarf star. Would anybody deny it's a star?
Yeah, it's a dwarf. Most people don't know it's a dwarf star, but it's a dwarf.
True. Yeah. That's pretty good, Neil.
Oh, we're shaking hands. Uh-oh.
On camera. Because Neil just said dwarf planets are planets.
We can edit that out. You guys edit that out later.
You probably will.
No. Guys, I told you to edit that out. Why is it still in there?
Oh, my God. Let me just say, that is a deeply wounded man you're talking to right there. I mean, he just went Taylor Swift on you. Like, we are never getting back together, Neil. Never. It's a planet, damn it. It's a planet.
So, David, what's your take on all this?
Well, you know, you heard me earlier in this conversation use the word planet, and that's almost my reflex. Like, I wasn't trying to be provocative or make a point then. It's honestly how I think of it. And I do understand how people that are concerned with thinking about orbits and classification of gravitational influence, you know, might put dwarf planets like Pluto in sort of their own category. Mm-hmm. But as a planetary scientist, you know, I go to meetings where we talk about planetary geology and processes of planetary atmospheres. And when we're doing that and we're doing comparative planetology, we do use the word planet often when we talk about Pluto. We're saying, well, you know, this planet has a crater population that shows that this area is young. And people don't stand up and go, wait, you know, they correct and go, no, you mean dwarf planet.
That's because they've all been brainwashed.
That's right. Exactly.
And can I just put it this way? Would this be fair to say, to look at dwarf planets and bodies such as Pluto, the way the statement would be, all human beings are apes. Not all apes are human beings. So could it be something along those lines when it comes to dwarf planets?
Well, yeah. I mean, I thought the conversation between Neil and Alan that I just listened to was pretty interesting because to me, I definitely don't have a problem with the reclassification. I think that, you know, we've learned enough about these other objects and even about the exoplanets, which they didn't even really get into, to re-examine the word planet. But I always thought it was a little funny to say and a dwarf planet is not a planet. That was the part that seemed like sort of an add-on.
Like a dig. That was a dig, you're saying.
Right.
So what I did, because of my episode dealing with the public and Pluto at the museum, I published a book called The Pluto Files, The Rise and Fall of America's Favorite Planet.
Nice.
And in there, it's a fact-based, and at the end, I save one little section where I have a 2-page expression of my opinion. And all I say there, and David, you're a sensible guy. I don't see why you would object to this, but I want this on camera to verify once I tell you.
Sweet.
So that what we really need, and this echoes a little bit of what Alan was saying, the word planet is not a useful word anymore. When I say planet, I just discovered a planet around another star. Oh, is it rocky? Is it gaseous? Is it near? Is it in a habitable zone? Might it have life? Does it have an atmosphere? You have to ask me 20 questions after I hand you a classification. That tells you the word needs improvement.
So the classification is far too large.
Far too large. And so we should have 20 different classifications, 20 different things should be like rocky objects and gaseous objects, objects with rings, objects, and then find some words for that. That way I can say I found one of them, and then you're right there.
Absolutely. I mean, we've always had gas giants and terrestrial or rocky Earth-like planets.
It's already ready to it's ready to happen. Right?
We didn't know that there were more kinds of planets, and we're discovering so much in our own solar system and wonderfully around other stars that, I mean, we definitely are evolving the way we think of planets. But
and I think they should have waited. We should wait until we get a nice, well-defined catalog of exoplanets, so that when we finally lay down a new set of definitions, it includes not only this solar system, but all others yet to be found.
Nice.
Well, I mean, the definition's going to be reworked again, because we're at our infancy of learning about exoplanets. And you know, the IAU, when they made this...
International Astronomical Union.
When they made this vote about Pluto, and I agree, I mean, I think most people agree that vote wasn't the last word and that it wasn't that well done. A lot of people that even sort of agree with the decision acknowledge that was sort of rushed and everything. But also another thing is that they didn't really deal with the exoplanets at all. They were just like, well, we'll wait on that. And so now you have the sort of absurd situation where almost all the planets in the universe, basically all the planets in the universe, are not included in the IAU definition of a planet, in the official definition. So I think there's going to be another stab at it. And maybe they'll take another look at this question of whether dwarf planets need to be defined as not planets or simply as another kind of planet. You know, in a certain sense, I don't really care. It's a little bit distracting. I mean, what's really cool is the fact that we've learned about all these new kinds of objects. I refer to them as planets. I can't help it. But, you know, as long as we're talking about them and people are interested in them, then the nomenclature isn't the most important thing.
Well, coming up next, more about Pluto's largest moon, Charon. David, am I pronouncing that right? Charon.
Yes.
Good, thank you. And New Horizons' continuing journey into the Kuiper Belt when Star Talk returns.
You know, fresh, high-quality ingredients taste better and are better for you. So it's important to know where your food comes from. I know where my food comes from. It comes from my kitchen. But where's it come from before then? Well, if you're like me, then it comes from Blue Apron. For less than $10 a meal, Blue Apron delivers seasonal recipes along with pre-portioned ingredients to make delicious, home-cooked meals delivered right to your door. Blue Apron knows that when you cook with incredible ingredients, you make incredible meals. So they set the highest quality standards for their community of artisanal suppliers, family-run farms, fisheries, and ranchers. Whether it's Japanese ramen noodles, wild-caught Alaskan salmon, or heirloom tomatoes, Blue Apron brings you the best. Not to mention, you can make some meals that you'll want to take a picture of and put on Instagram. That's right. How about spinach and basil pesto gnocchi with summer squash, green beans, and fresh mozzarella? Or summer vegetable pizza with garlic, lemon, broccolini. That's right. Pizza that you're making at home, and it's going to be absolutely delicious. So here's what I need you to do. Go to blueapron.com/StarTalk and get your first 3 meals free with free shipping. That's right. blueapron.com/StarTalk. books.com/StarTalk. Your first 3 meals free with free shipping. We're talking about the best ingredients, the highest quality food possible, delivered right to your door with your first 3 meals free with free shipping. Hey, what do I have to do? Eat this for you? If you're a man, you're going to screw up. Just ask your wife. Seriously, ask her. Go ahead. I'll wait. See, you know I'm right, so that's why you're not going to do it. And when you screw up, you got to smooth out those edges, man. And the way you're going to do that is with the Books.com. No woman in her right mind would turn away a peace offering of Books flowers. Books flowers are grown at eco-friendly farms on the side of a volcano. Okay, that's right. I'm serious. On the side of a volcano. And that makes the blooms larger, the colors more vibrant. It's a better soil, more sun at a lofty 10,000 feet kind of thing. Yeah, they're gorgeous flowers from the Books.com, hand delivered to your girlfriend or your wife to say, hey, we're still good, right? And apologies don't cost much at thebooks.com because Books prices start at a mere $40. There's no upcharges, no extra fees. Even delivery is absolutely free when you register with the Books. So here's what you need to do. Go ahead and get your behind out of that sling, my friend. Go to Books.com and enter promo code StarTalk to save 20% off the bouquet of your choice. That's BOUQS.com, promo code StarTalk. That's Books.com, promo code StarTalk. And when she says, did Chuck tell you to do this? You say, no, baby. This was all my idea.
Bringing space and science down to Earth. You're listening to Star Talk.
Satellite of love. Satellite of love. Satellite of love. Satellite.
Welcome back to Star Talk. I'm here with Chuck Nice.
That's right.
And our guest via Skype, planetary scientist David Grinspoon.
It's a funky spoon.
That's because that's his handle. That's his Twitter handle, Funky Spoon. David, why are you funky?
Well, some of us are just born that way.
Right on. Nice.
As you know, I play music too, in addition to
Okay.
science, and so
All right, we'll give it to you then. We'll give it to you.
Just can't help it.
For now, you're borrowing it. We need more evidence. Well, featuring my interview with Alan Stern, lead investigator of the New Horizons mission to Pluto, NASA's mission to Pluto. And let's talk about their moons. All right. For the longest while, we didn't even know Pluto had a moon.
But you know what? Here's the thing. Well, before you get to that, because I know you teased that talking about Sharon, I need to talk about the fact that I just want to know how you feel about getting hate mail from children for killing Pluto.
Oh, yeah, because I got blamed.
I know you got blamed. And you know what's funny? I hate to say this, but Alan almost blamed you earlier when we heard in that clip. It was like, you and your team, Neil.
Right.
And it was almost accusatory the way he stopped short of the. He stopped short.
I have a file cabinet drawer of pissed off, angry third graders. Whole classes, the teacher organized rebuttals.
Yes.
Okay?
Look, I happen to have one right here.
Well, you got one?
Yes, I do. Dear Dr. Tyson, you are a big poopy head.
I remember that one.
Pluto is my favorite planet. Okay?
Yeah, I was a poopy head in that moment. Yeah. So, and yes, yeah. So I was like the leading edge of this. David, can I get some sympathy or something from you for that?
Well, yeah, of course. I was working at the Denver Museum when all this came down, and I'd have kids, freaking out and wondering what happened to Pluto. I mean, people get very emotional about it.
Why is that? Why is it? I mean, seriously, if you said to me, like, Venus is our solar system's whore, nobody would get mad. Be like, oh, well,
Okay, fine. Yeah, I think it's...
What is it?
I think in America, that's why I subtitled my book, The Rise and Fall of America's Favorite Planet.
Right.
Because an American discovered it. And it was discovered the same year that Walt Disney first sketched the dog that would get the name Pluto. So, and when you're a little kid, when do you first learn about the solar system? In like 3rd or 4th grade?
Right.
When are you first doing cartoons?
Yep, same time.
Around the same time. So
at the time you learn about the planet, you're learning about the dog, or you're admiring.
Exactly. So I think Americans had a little extra attachment compared to the rest of the world. I asked people in Europe, in France, I said, "Do you care that Pluto's, quote, demoted?" I don't care.
Are you kidding me? Pluto is a peasant planet.
Hey, Chuck, I got to tell you, it does upset me a little bit when you talk about Venus in that way. But it is.
Of course, it would upset you that way.
I think there's something about it being small and kind of an oddball and maybe a little bit of an underdog.
Gotcha.
That people were sympathetic with Pluto, and it's actually a very interesting phenomenon.
Well, plus we would learn that Pluto had a moon in 1978. A moon of Pluto was discovered named Sharon. Sharon, which was the name, correct me if I'm wrong, David, the name of the ferry boat driver that would carry your unfortunate soul across the river into Hades. Is that correct?
Yeah, it was also the wife of Jim Christie who discovered Sharon. Was named Sharon.
Oh, so nice. Okay,
that was kind of a twofer there.
Mm-hmm. Okay, and so some people pronounce it Charon, but Sharon works for me. And also it's not only Sharon, but it's got 4 other moons. So Pluto has at least 5 moons. Is that correct?
Yeah, and actually it has only 5 moons. I mean, as far as we can tell, one of the things New Horizons did was look really carefully to try to discover other moons, and they actually were very careful because there was this worry that they might hit something. So there was this whole hazard avoidance sense of we really got to make sure there aren't any other small objects in orbit around Pluto.
That would be embarrassing.
Yeah, exactly. Something really tiny would doom the spacecraft at those speeds. But all they found was this one giant moon, Charon, which we already knew about, and then these 4 smaller moons, which are named Nix, Hydra, Kerberos, and Styx. And
wow, you're right. Everything does have to do with death around Pluto.
Yeah.
Well, this was the thematic relevance. All the moons of Jupiter are named of Greek characters in the life of Zeus. Zeus being the Greek counterpart to Jupiter. So we try to be mythologically consistent. And why not? Just as an homage to the Greek and Roman history of all of this. So during the flyby, the New Horizons mission also got a good look at Sharon. And so I asked Alan Stern about that. Let's check it out.
It's 1,200 kilometers, 750 miles across. It orbits pretty close to Pluto. So if you were standing on Pluto, it would be much bigger in the sky than seeing a full moon. And also, it's about as bright as a full moon because it's icy and very reflective.
Oh, because the moon itself is not very reflective.
Our moon is kind of just dirt. It doesn't reflect.
It's just dark dirt.
Right? But Sharon's icy, and we've discovered that it had a really interesting geological pass. It has the largest canyon
Wait, just
system.
to be clear, as bright as a full moon looks to anybody at night, it would be much, much brighter if it were made of ices or something more reflective than its current substance. So,
I mean, our moon.
Our moon, right. Yeah, I just want to make that clear, because people talk about how bright the moon is. Or I can read by moonlight or jog by moonlight. But it would be way brighter if it weren't so dark.
Exactly.
Right. Okay. Yeah.
Yeah. As a matter of fact, so we've learned that Sharon has something no other place in the solar system has. It has a dark pole, like an antipole or cap. It has no atmosphere, but it apparently used to in the past, because there's some telltale evidence of that. There's evidence that it used to have an ocean on the inside, like Europa.
Whoa, because Europa has a subsurface ocean. Yeah,
right?
Okay.
We found that the inside has ammonia ice in it. And we see that in the ejecta blankets of craters, where we can tell the composition of what came out of the center.
Ooh, so there's a term for that. I never knew it had a term. So an asteroid or some impactor strikes, and it makes a hole deep enough that whatever's below the crater range splashes up.
It excavates that
material.
Yeah. And Sharon's got this enormous canyon system that dwarfs the Grand Canyon. It's just another cool place.
I think we need to rename our Grand Canyon. Because now that we've got there's the Mars, everybody's got a canyon bigger than Earth.
What do you think?
We got to rename this.
Even Pluto and Sharon. Yeah.
So, Dave, you got a name for our Grand Canyon? The not so Grand Canyon.
The Baby Grand Canyon.
The Baby Grand Canyon. Steinway Baby Grand Canyon.
We'll have it sponsored.
It's a somewhat impressive canyon.
So, David, what else can you add about Sharon?
Well, Sharon is another delight. You know, even on its own, it was almost worth the price of admission of getting there. It's got some strange features. For one thing, it has this northern cap that's significantly darker than the rest of the moon.
Yes, Alan said it's kind of an anti-ice cap, right? It's dark.
Yeah, exactly. And there's some suspicion that it might have to do with exchanging gas between Pluto and Charon, if not at present, maybe in the past.
Now that system is tipped, right? That orbital system is tipped relative to Pluto's plane of orbit around the sun. Is that correct?
Yeah, exactly. But it's, of course, it's tidally locked now. So if you were on Charon, there'd be one place on Charon where Pluto would always be overhead, and you could just stay there and go around and watch Pluto go by.
In other words, Charon does not rotate relative to Pluto.
Yeah.
Yeah. It always shows the same face.
Yeah.
Yeah. Oh, wow, that's pretty cool.
Yeah, it's very cool. So it's double tidal lock.
Yeah.
Yeah. Did I tell you? In high school?
No.
I didn't tell you?
No.
I didn't tell you?
No.
Okay. In high school, I wrestled in high school.
Well, that I knew.
Okay. I was undefeated, and I was captain.
Okay.
I was kicking some serious ass, and I wanted to invent a new wrestling move called the double tidal lock. Doesn't it sound like a move that has to have that name?
Right.
Okay. So, but I never perfected it, but I'll show it to you later.
We got to no, don't show me.
So, David, tell me about moons. Our moon, they've been talking for a long time about moons being important to develop life on a planetary surface. Why? I've never really agreed with that connection. Maybe you can bring me on board.
I don't know if I agree with it either strictly, but the logic is that on Earth, our giant moon, and by the way, Earth and Pluto have in common that they have the two giant moons in the solar system as far as the relative size of the moon to the planet. You know, Earth's is rather extreme. Pluto's is even more extreme as being a sizable fraction of the planet.
Yeah, in fact, for Pluto and Charon, the middle point of their gravity is outside of the physical body of Pluto, right?
So it's a double planet.
It's basically a double planet.
Whatever.
Damn, you got me to say planet.
I was just about to say. You just said planet.
This is diabolical plot. Okay, go on.
The idea on Earth is that the moon stabilizes Earth's climate by acting almost as like the outrigger on a canoe by preventing the axis of Earth from wobbling more. And it certainly has played that role. Now, whether you could say without the moon, Earth would be lifeless or would just have life that had adapted to somewhat more wobbly climate, I'm not sure. But that is the idea.
Yeah. I did not know that. Yeah. So the moon, our moon, acts as a keel, kind of?
In a way, yeah.
That's amazing.
That's right. That's exactly right. And so
gravitational keel.
A gravitational keel.
But I would say look at the temperature range over which we survive or even thrive anyway.
Right.
On Earth. We have humans living at the equator.
That's true.
And Eskimos living
in the
Arctic.
Right.
So I don't think that we would fear that as
plus, I agree with you. I mean, you can imagine somebody looking at our planet from some other kind of planet and going, "Oh, look at these seasons. They have winter and summer. Nobody could possibly live there." It may just be that kind of argument.
Okay, cool.
So New Horizons went by Pluto and it kept going on a flyby, and it's looking for other stuff out there in the Kuiper Belt. I had to ask Alan Stern, what's next for New Horizons? Check it out.
So back in October, November, we fired the engines a series of times to target it for its next flyby. It's about 1 billion miles past Pluto. It's a building block of these small planets, like Pluto and Eris and the others. Mm-hmm. It's about the size of Chesapeake Bay. Mm-hmm. It's 4 billion years old. It's always been in the deep freeze, so it's scientifically a great sample of that early era.
Okay.
It doesn't have a really good name yet. It has a license plate. It was detected by the Hubble for New Horizons. It's called 2014. Which is the year it was found, MU-69, which is a jawbreaker.
Okay.
So we'll do better. We're going to have a naming contest with NASA and pick something.
Good. So that's going to be another flyby.
That'll be a flyby.
All right.
And we know when. It's a very easy date to remember. It's January 1st, New Year's Day, 2019.
2019, okay.
Yeah.
I'll put that on my calendar. And, again, you're flying by. Do you have fuel for yet a third destination?
Probably not, but we have plenty of fuel to run the spacecraft on a Voyager-like mission way out to the heliosphere.
Oh, okay.
Yeah.
Because that uses less energy, of course.
Yeah.
Okay. And, of course, this is the fastest spacecraft ever launched from Earth.
Right? It is.
And you will leave the solar system the way Voyager did.
Exactly.
Okay, will you ever overtake Voyager?
No.
Oh, that's too bad.
And a lot of people wonder why. If it was the fastest launch, how was Voyager ahead and staying
I
ahead?
think because Voyager cheated. It got some extra boost from Jupiter, I bet.
It got 4 boosts, one from each giant planet.
Oh my God, I didn't know it was all
Right?
4?
Yeah.
Oh my God.
And we only got Jupiter, so they're a little faster than us.
Okay.
But that's fine.
Okay. So this is stealing some of the orbital energy of a
giant planet.
and you get a little boost out of that.
Yeah.
Okay. That's fine. I don't think the planets mind.
I don't think they notice. They're inanimate objects.
So, David, tell me something about the Kuiper Belt. It's real enough and it extends out there?
It's, the Kuiper Belt is this vast outer realm of our solar system that we really didn't even start to learn about until, the 1980s and 1990s. And
by the way, it's not a coincidence. It's not simply a coincidence that that's around the time where people are wondering whether Pluto just belongs in the Kuiper Belt as a species of object, right?
Absolutely.
Yeah.
No, I mean, that was the discovery that led to this whole question of reclassification.
Right.
Was the fact that there are lots of objects out there, not just Pluto, and that led some people to say, "Oh, well,
How many is lots?
oh gosh, it's."
By the way, when you're funky, you can't use the word "gosh." Okay? Just those two.
Well, damn.
There you go. That's funky.
Gosh darnly. Golly gee.
Diddly do.
I'm telling you, only borrowing that funky moniker. You got to keep earning it. But go on.
There are millions of objects in the Kuiper Belt. Because you get to smaller and smaller objects, and there are just little chips of things too, because it's been collisional in the past. So it's vast, and
you call them objects, but what we can call them comets. They're icy, right?
Yeah, well, exactly. If you took them into the inner solar system, a lot of them would turn into comets. They'd start to develop tails and evaporate material.
Like Pluto would do. Yeah, go on.
And, the larger ones are, as we've been discussing, dwarf planets. The larger ones are round because of self-gravity.
Mm-hmm.
So there's a whole spectrum of objects. It's a vast realm. It's, in a lot of ways, it's the largest part, the main part of our solar system in terms of number of objects and in terms of the volume of space it takes up. And it is a belt, by the way. It's not a sphere of comets like we have farther out in the solar system. It's concentrated along that plane where the planets all.
So you have the Oort cloud, which is an icy body of comets, a zone of comets, which is spherical, so we call it a cloud. And this is a belt like the asteroid belt, which is kind of slightly flattened in a plane. So this is the lingo. Yeah. Okay.
Yeah.
Mm-hmm.
It's a thickened belt. The objects are they're not all neatly in that plane. They're all a little bit tilted so that it's a fat belt, but it's not, they're not isotropic. That is, they're not equally in all directions. They are concentrated in the plane that the planet's orbiting.
So this will go on for how much power does the thing have to keep going?
It's supposed to, in terms of it's got a plutonium power source, and
quaint.
So
Very nice, isn't it? It's plutonium. Yeah.
We send plutonium past Pluto.
Yeah, not uranium. That would be a Uranus thing. But
it's going to slowly lose power, but it's going to last for decades, probably at least until the 2040s. They should be able to stay in contact with it, just as we've been able to stay in contact with the Voyagers for decades after they completed their primary mission.
And just if I remember correctly, you cut your teeth on Voyager, didn't you, back in the 70s and 80s?
Yeah, I was a student, an undergraduate intern at the Voyager Jupiter encounter in 1979. That was a really life-changing and mind-blowing experience.
Wow, we have so much in common. I watched every episode of Star Trek Voyager.
Yeah, pretty similar in some ways.
And you that might have been your first encounters with Carl Sagan at the time, who was active with Voyager?
Yeah, Sagan was a mentor of mine then, and just getting to see him work and interact with the rest of the team. And, of course, they were filming Cosmos, the older Cosmos. And so there were like film crews in there while they were looking at the first pictures from Jupiter. And, as a wide-eyed undergraduate kid, that was a pretty mind-blowing experience.
Nice. Well, when we come back, we're going to talk about Planet 9. What is that? Ooh, it's a hypothetical planet could be hiding in the farthest reaches of the solar system. When Star Talk continues.
Skyward, left or right, I'll do what I like. All the places I'll go,
space, the final frontier. These are the voyages of the Starship Enterprise, its continuing mission. Now, see, if that excited you, then you need to celebrate 50 years of Star Trek at the Intrepid Sea, Air, and Space Museum. The Intrepid Museum in New York City is the first venue in the United States to host Star Trek, the Starfleet Academy experience. Channel your inner Spock, become a cadet, and embark on a 12,000 square foot interactive journey. This immersive experience lets you put your skills and knowledge to the test as you enter orientation and visit 9 zones focusing on special training in language, medicine, engineering, navigation, command, and science. Once you've completed your training as a cadet, you'll receive your commissioning post. The experience even has the original costumes and props from Star Trek series and movies. And as an added bonus, the Intrepid Museum has Galileo, the shuttlecraft from the original series, on display. The exhibition is now open, and you Trek fans are not going to want to miss this. It's only for a limited engagement now through October 31st, 2016. Get a special $5 off using promo code StarTalk. Offers good for up to 4 full-price adult tickets, child or senior Star Trek tickets only. Use promo code StarTalk online or at the box office to receive your discount. Offer may not be combined with any other offers. Visit intrepidmuseum.org/StarTalk for tickets and information. Number 1. Set course for Sector 001. Intrepid Museum. Engage.
Bringing space and science down to Earth. You're listening to Star Talk.
We're back on Star Talk with my co-host, Chuck Nice.
That's right.
And our guest, in via video call, David Grinspoon, planetary scientist. David, good to have you, as always.
Thanks. Always fun to be here.
We're featuring my interview with Alan Stern, who's the PI for the New Horizons mission, the NASA mission to Pluto and beyond.
Yes.
And now, earlier this year, since, David, we got you online and you were outer solar system guy. Earlier this year, 2 Caltech astronomers asserted the existence of a planet 9 deep in our solar system. Mass maybe about 10 times that of Earth. So none of this little puny pipsqueak stuff.
Right. We don't have to worry about whether or not this is a planet.
Exactly.
Right.
Exactly.
Size does matter.
And I think the numbers they put out were like 20 times farther from the sun on average than Neptune. And it might take 10 or 20,000 years for it to complete one orbit around the sun. So I had to ask Alan, because it's
a long day, man.
That's a
long
year.
day.
That's a year.
Oh, that's a year. Sorry, not yeah.
Still.
Yeah, one revolution
would never turn one.
Yeah, never turn one.
Not if you're human. So I asked Alan Stern about this Planet 9. Let's find out. Tell me about Planet 9.
Pluto?
This guy. Again, I'm pummeling him again. Let the record show.
I was widely quoted, actually, I think it was Nadia Drake that did the article that asked me about that designation, which I really think.
See, that's a beef between you and Mike Brown.
I think
Mike Brown named it Planet 9.
Yeah,
right?
and I think that was disrespectful of Clyde Tombaugh and his living relatives and the legacy of what he did. So I was widely quoted as saying apparently Caltech professors can't count. That became a hashtag. Caltech can't count.
I missed this. Was this in a Twitter war?
Yeah, it was a Twitter war.
Okay.
But we had a good time. But, if you actually count all the objects that are small planets in the solar system, it's actually up around 23.
Yeah, it's a couple of dozen. And so, he probably should have. There are many more creative things he could have called it as a placeholder name. He could have easily just called it Planet X, and that would have been perfectly fine. It would have been even cool.
Yeah.
And it's mysterious.
With the X-Files.
Yeah, okay. And so, can you comment on how Planet 9 was discovered? Should we have as much confidence as Mike Brown did in the method?
Are you talking about Pluto again?
No, I'm talking about Planet 9. Oh,
we're not going to call
X.
it that. Not today.
He's not going to call it.
No.
Okay,
What would you like to call it?
Planet X. The object Mike Brown called Planet 9, which I'm happy to call Planet X.
Thank you.
Okay, could you comment on the method of how that was inferred?
So it hasn't been discovered.
Not directly, right.
And there have been many claims in my career of we think we can predict the planet. A lot of them fall apart. In fact, even the claim that led to the discovery of Pluto was they did the math wrong, and Pluto was found only through Clyde Tombaugh's hard work.
So, David, I looked at the research paper that made this announcement. It seemed pretty legit to me, using sort of gravitational
Calculations.
Thank you.
No worries. That's what I'm here for.
No, so you do the inverse calculation for the gravity equations. Normally you say, here's the mass, what is the force of gravity at some point?
Right.
But instead, what you say is things are behaving in a way that is surely the result of some source of gravity we don't know anything about. Let's look at how they're behaving and infer the existence of a source of gravity elsewhere in space.
Gotcha.
That's basically what they did, David, correct?
Yeah. I mean, I think it's a good piece of work, and it's definitely legit. Whether or not their specific prediction will pan out, who knows? I mean, as Alan said in your discussion with him, there's a history of this kind of prediction being off. It's a hard thing to do. But certainly they saw a pattern in the orbits of other objects that seems to be non-random and seems to imply the existence of some other mass. And, what's great about science is they made a prediction. We'll look, either the object will be there or it won't be, and science will move along. But I think, as Alan said also, there are bound to be a lot of objects out there. We are going to find other planets in our solar system.
Where did they come from?
Well, the origin of the solar system was messy. There was a shuffling around of the giant planets, and a lot of pretty sizable objects got tossed out. That's why we have a Kuiper belt, for instance. There was this tossing out of planetesimals, of the little planets, and some not so little ones got shuffled around as well.
Wait, just quickly. So you're telling me the Kuiper belt was not left over from the origin of the solar system. You're saying it may be the castaway debris from what was going on from with the inner solar system.
Yeah, I mean, well, it's left over in the sense that it's a remnant of that process, but that process was one of shuffling around and tossing things out of the inner solar system and ending up elsewhere. There was a lot of chaotic...
It's our inner solar system's junkyard, basically.
That's what you're saying.
It's our inner solar system junkyard.
So it might have so there's some what you're saying is there are much larger castaways out there. If this prediction is correct, it might not be the only one, because we only happen to infer its presence because it has a visible effect on other Kuiper belt objects. But there could be many large planets out there, is what you're suggesting.
Yeah, I think there should be, based on what seem to be the best theories we have of solar system formation. And it may be that, this specific prediction, even if it's wrong, will lead us to other things. I think we will find more planets out there.
So is this going to give us another source of predicting mass extinctions on Earth? That this thing only comes around every 10 or 20,000 years? That'll disrupt Kuiper belt comets and send them raining down on Earth?
Well, it could. I mean, you're referring to, there was this idea of nemesis, which was basically a companion to the sun, which every once in a while would disturb the outer cloud of comets and send objects in. The problem with that is that I think the evidence that there's a periodic signal that extinctions come in regular intervals isn't really very good. And so it may be explaining something that doesn't really need an explanation, So I'm kind of skeptical of that, just because I don't see the signal in the data of Earth.
So it turns out, in addition to Planet 9, Alan Stern told me Planet 9 could just be, Planet X.
Planet X, right.
Could just be the tip of an iceberg of many, many larger planets in the outer solar system. Let's check it out.
Modern planetary science is pretty sure that as we can look further and further with better and better technology, we will find more planets further out, and lots of them, and even big ones. And
big ones like Neptune size, like
certainly Earth size.
Yeah, at least Earth
the
size.
models suggest that Earth size planets in the Oort cloud are a good bet.
So we should watch that space.
Yeah, we absolutely should. It'll be exciting.
Yeah.
But we're going to have to get used to the number that there are just large numbers of planets, just like there are large numbers of stars. And who knew in the 20th century that the solar system was so good at making so many planets?
And are some of these planets, do we think, escaped from the inner solar system and they're just sort of wandering out there?
Well, a lot of the ones that are in the Oort cloud came from the middle solar system, the region of the giant planets. When the giant planets got big, their gravity was enough to clear out all kinds of stuff, littler stuff. It threw the comets to the Oort cloud. It threw a lot of comets out of the solar system altogether. It threw planetesimals, which are 10,000 times bigger than comets. It flung small planets around and even big planets, because Jupiter can haul an Earth all the way to the Oort cloud.
I didn't know that. Oh my God. Well,
Yeah.
yeah, of course. Why not? I mean, it's
In
Jupiter.
fact, there's a theory that some dynamicists work on that indicates that even a Neptune or Uranus may have been ejected. There may have been a fifth giant planet in our solar system. And so some of those things got thrown completely out into interstellar space, and some got stuck on the very edge of the solar system, the lip of the potential well, called the Oort cloud. And it's kind of the solar system's attic.
So once again,
got thrown up there, and we're going to go find it. When
so the more we learn about it, the more nuanced and the more complex it is. And that's a good thing.
Yeah, I think so.
David, give me some final reflections on all of this.
Well, the Oort cloud is a magnificent structure. We think of the stars as so far away, and our solar system is isolated. But if you include the Oort cloud around our star and those probably around others, then they're almost touching. I mean, the Oort cloud goes maybe a third of the way to the nearest star. It's something like a light year in diameter.
And just to clarify, we're not speaking of a gaseous cloud here. Mm-hmm. We're speaking of a volume populated by a swarm. I love that word. Yeah. A swarm of icy bodies.
Right.
Yeah.
That from a distance it looks like when you say a cloud of bees.
Right.
Same kind of thing.
Same deal.
Yeah, and it's an isotropic sphere, meaning that it's not flat like everything else in the solar system. It's completely round. There's many comets in any direction you can point from the sun. And it's the sort of reservoir of icy stuff that once in a while something gets disturbed by a passing star or one of these planet X's or whatever, and comes flying in towards the sun, and that's when we see it develop a big tail.
So what's cool, I think, if a comet comes in from above the solar system, we know it's going to be an Oort cloud comet, because that's the only thing that actually has comets that can come from that direction.
Gotcha.
Right. So Chuck, what do you make of all this?
Well, I think that it's very clear that people are passionate about planets, which I think is a good thing. And I just love that there are scientists having Twitter wars like Donald Trump. I think that is awesome.
So Twitter wars over things other than Donald Trump's hair.
Exactly. I think that's great.
What I like about it is the idea, which is an emergent discovery, David, correct? That many things that we identified as planets in stable orbits around host stars could have been flung from those host stars and could just be wandering interstellar space.
Absolutely. And when Alan mentioned a Neptune getting thrown out of our solar system, I couldn't help but thinking, well, does that mean that one of these days a Neptune's going to come flying into our solar system?
Yeah, be a flyby. Yeah. It's like, what are you doing in my neighborhood?
Right. I thought I told you never to come around
I want to see what's going to happen if a Neptune comes flying.
But what would be cool is if some of those planets still had a residual heat source, such as Earth still does.
Right.
And if that's the case, you could have life possibly evolving on planets.
On a totally rogue planet.
On a totally rogue planet.
Right.
And they will know nothing of a host star as they wander through space.
We don't need no stars.
We don't need no stinking
Don't need no stinking stars.
David Funky Spoon, David Grinspoon, thanks for being on Star Talk. And again, welcome to the community of Star Talk All-Stars. Look forward to seeing you in many ways and times.
Thanks a lot, Neil.
And Chuck.
Yes.
Always good to have you, man.
Always good to be here.
When Star Talk returns, Chuck Nice and Bill Nye take over the studio for a segment of maker-themed cosmic queries.
Yes.
Brought to you by Google.
Support for Star Talk comes from Google. The Making and Science team wants to spark the curiosity of aspiring makers and scientists, encouraging them to explore the world around them, to tinker and build things, and to have fun doing it. Learn more at makingscience.withgoogle.com.
Bringing space and science down to Earth. You're listening to Star Talk.
Welcome to Star Talk Radio Cosmic Queries. This is a special edition, Chuck.
Yes.
This is the Maker Edition. It's brought to you by Google.
Yeah.
And if you're listening, and I believe you are, when you get where you have access to the internet, check out their website at makingscience.withgoogle.com.
Nice. No other way to make science as far as I'm concerned.
With Google?
That's the only way to do it.
Okay, I'm sure you're right. There are no competitors. It's all good. No, this is Star Talk, and we got queries from you. You have enquired. And by long tradition, our worldwide citizen, Chuck Nice, will read your queries. And he and I will comment insightfully.
Indeed. One of us will. That'll be you.
All right, we'll try.
The other one will just read them.
That's you.
That's me. Okay, here we go. This one coming to us from Necro7 on Twitter.
Necro. A little troubling.
Necro7.
A little troubling.
Yeah.
All right. And it's Necro. What does he or she have to say?
Says, how would you compare the effects of accessible 3D printing today to the effects of the printing press in the early Renaissance?
I don't think it'll be quite as influential. The printing press was a big thing.
Yeah.
However, 3D printing is absolutely the future. And I talk about this all the time. I'm imagining where we're making, maybe I am wrong, as is so often the case. We use the term in mechanical engineering, additive manufacture.
Additive manufacture.
That's what 3D printing is.
That's 3D what?
But when you think of, this word machining.
Yes.
Where you cut material.
Right.
Yeah, you make a screw, you cut the metal away.
Right.
Or what have you. So this could revolutionize all that we know and love.
So you could possibly at one point envision a world where you just 3D print everything?
Everything would be custom made. There wouldn't be anything adjustable. Everything would be made perfectly.
No, when I think about the economic repercussions of
belts wouldn't even have more than one hole. The belt would be made, and there'd be a single hole for your waist.
Well, that's it. You've sold me.
No, but I mean, I can imagine it easily. Yeah,
right. Because
you go to the store, and there's designers there. I'm thinking about fashion now. Fashion. You go to the store, and they custom make it for you, and they almost sort of do that with Neil's suits.
Yeah.
He gets them multi-measured at multimeasure.com, and then they fit him better. And so I could easily imagine that the future, everything is customly 3D printed. Yes, you were saying you started to go wide world on us worldwide.
I'm thinking, what do you do with all the jobs of people who were making the screw that now...
Somebody's got to make the printers.
So all those people are now just making printers.
Well, or they're doing other wonderful, productive, artistic, wonderful, life-enhancing things. Thinking deep thoughts about how to make better printers, how to design new things. Everybody becomes a designer. Everybody's a designer. Everybody custom makes everything. Come on.
That's a scary world.
Cheer it up, Chuck.
I'm going to say that, because where I see this going is...
Let me just ask you about that sentence. I'm going to say, yeah.
No,
can you expand on that just ever so?
That right here, just a little bit. 3D printers making 3D printers, and now we're done. Now nobody works anymore.
Well, but who's shoveling the coal? That is to say, who's making the electricity? Somebody's going to have to do something.
Somebody's got to do something.
Somewhere.
All right.
Notice that people are as busy as ever. You say, what did they do in the good old days? They churned milk, they grew crops, they tilled the soil, they got rid of the weeds, what have you. It has not led to a life of leisure.
Right.
You wash the dishes automatically while you're doing a bunch of other stuff now.
Right. Okay.
Humans are busy humans.
Okay. All right. I'm going to go with you.
Bees. Only humans.
All right, let's get to another question. This one from Twitter says,
does it have a name, Twitter?
No, just Twitter. And
Twitter's on Twitter.
Twitter is on Twitter.
Somebody secured that name early on.
Well,
yes, so hello, Twitter.
How would I love to get that name? That'd be my Twitter handle.
No, you wouldn't. It wouldn't say Chuck.
It would say at Twitter, though, and everybody would know that that's me.
You're the man.
Everybody would have at Twitter. Everybody would have that.
You figure you'd have a lot of followers, and that would lead to a pay raise.
Right. Because that's what you got to do nowadays to get a pay raise.
That's what I'm saying to you. So Twitter has a question.
Twitter wants to know this. How does 3D printed materials, carbon footprint, or other environmental strain metric compare to that of manufactured products? So, is it on equal footing? Is it a less of a carbon
footprint?
footprint?
Maybe less footprint. if you could efficiently ship the material to where you need it and then manufacture in situ, then you wouldn't have all the bulky, like for example, I'm looking here in the studio at stools or a sofa. The packing for those things is large.
True.
If they could be manufactured closer to where they're being used,
No need for it.
you'd have probably more efficient shipping of the raw materials.
Right.
You know what I mean? You wouldn't have that volume. Just in these couple examples looking around the room here.
So now, do you think that it might lead to a more disposable world?
Or a
where
more
people are-
recyclable world.
Ooh.
The couch is made of magic plastic that you just melt down and make into a new stool or ottoman or settee or headboard.
So the real...
Or even dresser drawer. just doing a furniture thing. So you were saying.
No,
or maybe a mattress.
So the idea is you would have to make materials that can be used again and again.
Well, I mean, it's certainly reasonable. I mean, the 3D printed plastic that we're using now is melt-downable.
Right.
If I can coin that adjective.
I love when you get all sciencey on me like that. It's
nibonic. Melt-downable.
Okay. Let's move on.
Moving on.
Kevin.
Cosmic Queries Maker Edition.
Kevin S. from Twitter. Kevin S. wants to know this. What's the strength of 3D printed metal parts, cast, forged, or billet of the same material? So if you got it strewn out of this little head, can it be as strong
I'm not
as
an
something
expert
that's
on
die
that.
cast or something that's forged or...
I'm not an expert on that, but I will say this. I saw a wrench made, and it was a little oversized, I think, for stiffness.
Okay.
And sintered parts. These are parts made from powder that is fused together, melted essentially. Those aren't as strong, but they have other properties. In the example of sintering, they hold oil for a bearing or whatever. That has an advantage.
Okay.
So I could easily imagine a secondary operation where you roll or press or smash the 3D printed part or additively manufactured part to give it strength. I could easily imagine that. And I guess as a host of Star Talk Radio, I should know more about that, and I will make a note to learn that.
All right. Well, there you have it.
But as a mechanical engineer, I can imagine a secondary operation of smashing to work harden it, to give it strength.
Gotcha.
You know how you can't straighten out a paperclip very easily?
Right.
Because after you bend it,
now you have to...
It's called work hardening. You've done work on it, and it gets stiff. It's the nature of the grains of metal.
Gotcha.
So very reasonable that you'd have to resmash, but that could be a lot cheaper than shipping a full-sized wrench to somebody.
All right.
trying to get that nut up under the sink. Maybe you just make the perfect custom-made wrench just right there.
Right for that.
And then you'd melt it back down after you're done.
There you go.
And have all those molecules floating around your house.
I like it. All right, this is Tim from Twitter.
Tim from Twitter.
And he's tweeting to us from @EvilNut.
Can't hear you, can't read you. All right, @EvilNut.
@EvilNut wants to know this. Are they testing or printing in zero G? It seems like it would be impossible in zero G.
They do it
metal.
They did it on the space station.
Because it's liquid. So
they did it on the space station. And the word liquid, it's gooey. It's amorphous. Okay. It's literally both as the adjective and as the noun, plastic. You know, the Earth's crust, the Earth's mantle,
right,
is said to be plastic.
Really?
Smush-aroundable.
So, because it's
hot. Hot.
Very hot.
So, and yes, they've 3D printed in space. By paying attention to what they're doing. The thing squirts out and the plastic sticks to the plastic.
Okay.
So you can shape parts of space even though you don't have gravity.
There you go.
In fact, there's probably an argument from 3D Print Co. that says gravity is a real problem. You should do all your manufacturing in space.
Oh, really?
Easily imagine somebody coming in here to say that, and I would not be in a position to disagree, Chuck.
There you have it.
I'd have to do the opposite of that. I'd have to agree.
So, although EvilNut, it's counterintuitive, actually, zero G.
Just imagine squirting toothpaste on squirt toothpaste on the wall. Now squirt another B sheet of toothpaste on the toothpaste, it would stick to it, right?
Right.
Even though you're upside walled.
Upside down, or no matter where
That's
you are.
right. Yeah.
Just
I mean, you can
squeeze it
imagine
right out
that
of the
it's
tube.
possible. Yeah.
Squeeze it right out of the tube and right onto the toothpaste, onto the toothbrush. Okay. This is a great question.
How does it go?
Thomas TJLK from Twitter wants to know this. Will people be able to 3D print medicine? So you're talking about manufacturing medicine.
Sure.
Really?
Imagine this. I mean, how hard can this be?
This is awesome.
They tell you to take 2 aspirin.
Okay.
They tell you to take 1 aspirin.
Right.
You just custom print the size of the pill you want.
So you have...
With your aspirin goo stuff.
So how do you dial up
the physician weighs you.
Okay.
And then prescribes the right size pill. Just for shooting from the hip, without even starting.
Okay.
Without even trying to make molecules from scratch.
All right, good.
Without even doing that.
Not even doing that.
Just right from the get-go.
Wow.
And then furthermore, at home, your bathroom scale is on the internet. It tells pill.com squirt machine how to squirt out the right size pill for how much you weigh, and then you're just perfectly healthy.
Damn, that's
And imagine it. I mean, it's one thing with aspirin, but imagine, there's so many people with all these other exotic disorders, and they have to constantly manage their dose, right? I can easily imagine a machine or a couple of machines that could do that.
So no more one size fits all
I can
prescriptions.
It's easily
custom
imagine.
prescribed for you.
Yes.
It's fantastic.
From prescribeco.com, there at your Rite Aid, your Duane Reade, your CVS. And this is where maybe you don't have the machine at home, but you have a bathroom scale at home. And it transmits your weight to your druggist, who then, when you show up with the prescription, the pills are just the right size.
Wow.
Whoa, how cool would that be? Like everything else on Star Talk, it is super cool. So this is Bill Nye here with Chuck Nice, worldwide citizen of the wide world. And this, you're listening to Star Talk. Keep looking up.